In chemical bonding, good evening friends. In chemical bonding, now I want to explain about the bond angle and also DRAGS rules. What is bond angle? Now I want to explain about the bond angle. If you take any molecule, if it like this, B, C, the difference between these two, theta is considered as a bond angle. Then how to find out the bond angles in different atomic molecules? Then I will explain one by one. For example, if you take 4 points we have to must remember. First is based on the hybridization. First point is hybridization on central atom. Hybridization on central atom means, for example, if you take sp3 hybridized, sp2 hybridized, sp hybridized. sp3 hybridized means bond angle is 109 degrees 28 minutes. This you have to remember. sp2 means 120 degrees. sp means 180 degrees. This means this is tetrahedral, like this. This is bond angle 120. This is sp means linear. This is about hybridization on central atom. For example, if you take methane, this is you take boron trifluoride, this you take beryllium dichloride, different molecule. If you take second, if must remember, if hybridization on central atom is same, central atom hybridization is same if lone pairs increases, bond angle decreases. Then we have to consider, if hybridization on central atom is same, then we have to consider lone pairs. If lone pairs increases, the bond angle will be decreases. So we have to find out this. If you take for example, hybridization is on central atom is same hybridization. For example, if you take methane, ammonia, water. Methane, ammonia, water. The hybridization is same in these cases. I will explain one more. sp3, sp3, sp3. What will we have to consider? Hybridization on central atom is same. In this case, oxygen, nitrogen, sp3, sp3. If lone pairs are increases, here 0 lone pair, here 1 lone pair, here 2 lone pairs. If lone pairs increases, bond angle will be decreases. This is the second point we have to remember. Next we have to consider next. Third point is hybridization is same. Hybridization is same on central atom. Lone pairs also, whatever it may be, 1 or 2 or lone pairs are same. Then we have to consider two concepts here. Then we have to identify, if central atom electronegativity increases, bond angle is increases. These two are same if central atom electronegativity difference is increases, but surrounding atoms will be similar. This is, remember, surrounding atoms same. Lone pairs are same. Hybridization central atom, lone pairs are same. Surrounding atoms also same. Surrounding atoms same. Surrounding atom same. If central atom electronegativity increase more, that is bond angle will be more. If surrounding atoms differ, if surrounding atoms differ, central atom is same. Central atom is same. Central atom is same. If surrounding atoms is differ, if it is electronegativity of surrounding atom is increases, bond angle will be decreases. This point, these 2 points very important. In this case, first one is, if you take ammonia and phosphine, here both cases hybridization is same on central atom, lone pairs is same, sp3 only, hybridization, lone pairs are same, surrounding atoms are also same, hydrogen. If central atom electronegativity increases, the bond angle will be increases. This is 107 degrees, this is approximately 93 degrees. Here in this case, what will happen if central atom, surrounding atoms are different? Which one is taken? CO, Cl2, CO, CO, F2, CO, Cl2. In this case, carbon monoxide, COF2, COCl2. In this case, what will happen? If surrounding atoms electronegativity will be more, then bond angle will be less. Similar concept here. These 3 concepts we have to remember. First is hybridization is different. Second one is lone pairs. Third one is lone pairs hybridization will be same. Then we have to central atom. Then we have to consider central atom, surrounding atoms are same, central atom electron difference more is the bond angle. If surrounding atoms are differ, central atom is same, surrounding atoms electronegativity will be more, then their bond angle will be less. These 3 concepts we have to remember, very important. This is about the concept on the bond angle. We will discuss about some of the examples then we can easily identify. Next, one of the important concept, some of the exceptions. To take for example, OH and O-methyl. I will give some of the examples, discuss which is bond angle is more. In this case, which one is having more bond angle? If you take central atom is same, the hybridization will be same. This is hybridization is sp3, here also sp3, lone pairs are same, all this same. But what will happen? The oxygen is more electronegative, this is attract towards. If you take a carbon and oxygen, which is more electronegative, here also towards the oxygen side. Compared to, in this case, this is less because carbon is more electronegative. Center here is carbon, here is hydrogen. Carbon electronegative 2.5, in this case 2.1. Due to strong attraction, this attractions will be more that compared to here. Due to this bond angle will be more compared to dimethyl ether. This is expected, but this is wrong. Why? Because due to the size, this is bigger size, the repulsions between these two is larger compared to water molecule. This is bond angle will be more compared to that one. This point you have to remember. If you take, for example, different molecule, if you take, I will give you some of the examples to discuss easily. NO3 minus, NO2 minus, NO3 minus, NO2 minus, next NO2 plus. For these molecules, how which is having bond angle will be more, which is less. This point you have to remember. Very, very important. They will ask in the question in entrance examinations. How do you find out? It is difficult, but I have to find out one by one. This is 1, this is 2, this is taken as 3. First you have to find out the hybridization. Then later, after that, lone pair. First you have to find out the hybridization. How you find out the hybridization? What is the definition? First you have to write the formula. Z is equal to, I will write the formula, hybridization formula, easily you understand. Right note. Z is equal to 1 by 2 into number of valence electron on central atom. Valence electron on central atom, I write the many times. Central atom plus, if the any molecule having positive charge, negative charge, that is added as a plus. If it is positive charge, that is added as a minus, plus number of monovalent atoms attached, monovalent atoms on surrounding central atom, on surrounding central atom. This is the formula of the hybridization, you can find out easily. If you take in this case, what is this one? 1 by 2. What is the valency of nitrogen? This is the 7th, means 2, 5. Write the electron. 5 is the valence electrons, plus. If it is negative charge, means plus. What is the, how much negative charge? 1. Positive charge is 0. Monovalent atom is not there. This is the oxygen is a divalent compound. That's why 0. 5 plus 1, 6. 6 by 2 means 3. 3 means, what is the hybridization? sp2. This you have to remember. This is the 1. Next, NO2 minus, you have to calculate. Say 1 by 2 into, say 5 plus 1, 0, 0, 0. Means 6 by 2, this is also same. 3, this is also sp2 hybridized. First you have to find out the hybridization, later we will. Next, NO2 plus, Z is equal to 1 by 2 into valence electrons is same, 5 plus negative charge is not there, minus positive charge is 1 plus 0 plus 0. 5 minus 1, 4, 4 by 2. 4 by 2 means 2. 2 is equal to sp hybridization. This you remember. First we have to find. If you, this is sp. sp hybridization is, just you remember, 180 degrees. But you have to consider the lone pairs also. This you later. If it is lone pairs, if you consider lone pairs, Z is equal to number of lone pairs. That is also formula. Number of lone pairs is equal to Z minus surrounding atoms. Surrounding atoms. Z is 3, number of surrounding atoms is also 3, lone pairs is 0. Here lone pairs, Z minus surrounding atoms. Z is 3, number of surrounding atoms is 2, lone pair is 1. Here Z is lone pairs is equal to Z minus number of surrounding atoms 2. 2 minus 2, 0 lone pairs. This is having one lone pair. First you have to consider the hybridization. sp hybridization, 0 lone pairs. What 180 degrees. sp2 means 120 degrees. This is also 120 degrees. Which will having the highest bond angle? This is having first. Third is highest bond angle. Next, in this case, if lone pairs is present, this is 120 or sp2 120, but in this case lone pairs are present. That's why this bond angle is less. If number of lone pairs increases, bond angle will be automatically decreases. Means this is very less compared to 1. Next to 2. 3, 1, 2. This is the concept of how to find out the hybridization. Means first one is NO2 plus is greater than NO3 minus is greater than NO2 minus. We can find out any molecule they have to given. We can identify easily the bond angles sequence. These points we have to remember. Some of the exceptions also we have to find out. This is about the bond angle concept. One more concept I want to explain, that is about the DRAGS rule. What is DRAGS rules? That is very, very important. Then I will explain. DRAGS rule. Next concept I want to explain. This is about the bond angles. We can by remembering 3 main points, we can identify easily the bond angle based on the hybridization. First point is hybridization. If the hybridization is same, if hybridization sp3, sp2, sp, we will know these sp3 109 degrees, sp2 is 120 degrees, sp is 180 degrees. If the molecule is hybridization is same, lone pairs are different, number of lone pairs increases, bond angle automatically will be come. This is the second point. In third concept, what will happen? If hybridization is same, lone pairs also similar. If it is 1, 0 or whatever doing. After that, what we have to consider? The electronegativity of the central atom, electronegativity of the surrounding atom. If electronegativity of the central atom is differ, more electronegative, more will be the bond angle. If electronegativity of the surrounding atoms is differ, more electronegative, lesser will be the bond angle. This concept you have to remember. Next, discuss about the DRAGS rule. What is DRAGS rule? How it is important, very, very important. Just have to remember some of the points in this case. What will happen in case of this rule? These points we have to remember first. This exists in the 14th, 15th, 16th, and also 17th. Nitrogen, phosphorus, 15th, 16th, 17th, 15th, 14th, 15th, 16th groups from third period onwards. From third period, second member hydrates. Second member hydrates will show DRAGS rule. What is DRAGS rule? So I will explain. First I will explain the concept, then later. Yes. This is very, very, very important. I will explain you. First you take this is nitrogen, ammonia, We take first concepts of this one. Molecules. NH3, nitrogen, phosphorus, arsenic, stibbium hydrates. These are the hydrates of the 15th group elements. What is the structure of nitrogen? This is the lone pair, this is the hydrogen, this is the hydrogen, this is the hydrogen. Remember, this is phosphorus, this is also lone pair, this is the hydrogen, this is the hydrogen, this is the hydrogen. Next, arsenic, this is having lone pair, this is the hydrogen, this is the hydrogen. Next, stibbium, this is also lone pair, this is the hydrogen, this is the hydrogen, this is the hydrogen. What is the hybridization here? This is also sp3, this is also sp3, this is also sp3, this is also sp3 hybridization. What is the bond angle? 109 degrees 28 minutes. This is 93 degrees. This is 92 degrees, 91 degrees. Which one is applicable here? Third concept, I will explain. Third rule, central atom electronegativity increases, bond angle increases. This is the concept. Means that's why this is having highest bond angle compared to this one. Up to this we have to remember, because in this case what will happen if the electronegativity difference is from nitrogen from nitrogen to phosphorus, it will not that fast will be decreased. This bond angle is decreases how much? Nearly 14 degrees approximately. 14, what will happen? 107 here. Not right. Nearly 107 degrees, small fraction. 107, 14 degrees. After this is decreasing is very less. By simple the electronegativity difference, this much bond angle will be decreases will not happen. What as DRAGS rule, what will happen? This is very very important. Nitrogen electronic configuration is 1s2, 2s2, 2p3, 7 electrons. Huh? This is having two lone pair and also single lone pair. What will happen in a hybridization? The mixing of these. This is the lone pair. Yes, the lone pair and these three unpaired electron will mix, will form sp3, 4 sp3 hybrid orbitals. Yes, no? This is also lone sp, one of the sp3 hybrid orbitals, lone pair also hybrid orbitals. This one, this one, this one. sp3s, sp31s, sp31s with these one of the lone pair containing s orbital, 3 px, py, pz orbitals will combined mix will form 4 sp3 hybrid orbitals. This is form the pyramidal shape. This is sp3 hybrid orbitals of nitrogen will mix with will combine with hydrogen 1s1 orbital will form sigma bond. Like this, 3 sigma bonds, one lone pair. After combining these 3 will form the 4 sp3 hybrid orbitals. But in case of phosphorus, same phosphorus, what is the electronic configuration? This is having 15 electrons, 1s2 hybridization for phosphorus, 2s2, 2p6, 3s2, 3p3. Means this is having lone pair, this is having 1 electron, this is px, this is py, this is pz. In this case of phosphine, what will happen? This will not part involved in the mixing of the, this is not mixed with the for hybridization, because this phosphorus directly formed with Px, Py, Pz with 90 degrees, they will form this phosphine molecule with the hydrogen 1s directly will combine with the hydrogen 1s1. They will form the molecule. This s orbital is not pure s orbital. This lone pair contains a pure s orbital, but in this case sp3 hybrid orbital. In this case it is pure s orbital. In this case sp3. This is not involved in the form the sp3 hybridization, but not mixing. After mixing will form the hybridization. It is not happen in this case phosphine, but in this case ammonia, it will combining mixing of these s and 3 p orbital will form 4 sp3 hybrid orbitals, equal energy orbital. But in this case not like that. Individually the px, py, pz orbital will combining with hydrogen 1s1 orbital will form 3 sigma bonds, but the lone pair will contain only pure s orbital only. It will not participated in the hybridization, but the overall hybridization is sp3, but here also sp3, here also sp3, sp3, but the p orbital will not mix with the s orbital. They will directly form with the bond with the hydrogen 1s1. They will form the sp3 hybridization. That's why the bond angle will be opposite 93 degrees, but in this case of due to the mixing of the orbitals, they will form the 107 degrees. This is the main difference between these two. That's why in the case of sp3, what is the percentage of s character of this lone pair is 25, but in this case of pure s orbital, percentage of s character is 100%. Means 100% means this is more electronegative. This is less electronegative lone pair. This is more electronegative lone pair. If it is more electronegative, it is difficult to donate this lone pair to other molecule. This is easy to donate to lone pair of electrons to another molecule, another different molecules. Due to this pure s percentage increases, this is closely attached to the nucleus. This is percentage of s character is less. That's why this is less to this one. This is easy to donate the electrons to the other molecule. That's why this is more basic compared to this one. This is less basic. These points we have to remember. What is DRAGS rule? This rule is applicable in also same like that. H2O oxygen, H2S oxygen, sulfur, tellurium. Same this like this. The bond angle will be decreases. Here also the pure p orbitals will be not participated in the hybridization. They will directly form with the bonding with the sigma bond and 1s1 hybrid orbitals. This is very important. The basic nature will be decreases. The basic is more, ammonia is more basic compared to phosphine, arsine and strontium. These points where this is about the DRAGS. So this exists in 14th, 15th, 16th group. This is exist in methane, carbon, silicon, germanium and tin like this. 14th, 15th, 16th group. This will show the DRAGS role. That is after the second one. After the second, third period this will exist, but in this case third period it will be existed. This is exist in the only 14th, 15th, 16th group. What is the difference? This is pure p orbitals will form the mixing with the hydrogen. They will form the sigma bond, not like sp3 hybrid orbitals. This is very important. This is more basic because this is s character is very less. Here pure s character is more electronegative. Percentage of s character is more. That is more s character, more electronegative. That's why this is not donate the lone pairs to the other molecule. This is easy to donate. That's why this is more basic compared to this one. This is very important. If you take for examples, some of the examples. This is ammonia plus HCl, phosphine plus HCl. Next, ammonia, water, phosphine water. This will react with the form H4Cl minus. This is not react because less basic. This is more basic. Next here ammonium. This will form ammonium hydroxide. This will not react due to the DRAGS rule. This is you have to remember. Now close the session. Next we discuss with some other concept. Thank you.